All right, so this video goes over how to make a full program in Botball. So I have a bunch of notes here, and it's basically just saying that this program that I'm about to make from scratch is going to be made for the small robot, not the Roomba. So by the small robot, I mean the robot with just the brain and you have to attach the wheels to it, that robot. Um, I'm going to be using commands that are specifically for that one because the Roomba takes other commands. And I'm going to be using functions in this, and I'm going to show you how I personally make my programs. And here actually is a little, this is my thought process on how I do it. I figure out first a simple repeating task that I want the robot to do, and then I experiment with in the main function. I try to just get the robot to do that in the main function, and then I make a little function for it. I make my own function, and I put the code that I experimented in here in my own function. So that's actually what I'm going to do. And I have, let's see, 5 functions that I'm going to make. So let's start. So the first one, be able to move forward and backward a certain time or distance. So in the parentheses, I have the pieces of code that you need for this function. All right, so let's see. So if we want to get the robot to move forward and backward, we have to use the MAV command. And let's do a certain time first. So forward or backward, that's going to be MAV. Okay, so little note here. Let's see, actually no, we can make this into a variable. So I'm going to make an int, which holds just a regular number, L motor equals 0, and then int R motor equals 2. So instead of every time I want to use the MAV command and saying, oh, I want to use 0 for the left motor and 2 for the right motor, I'll just put L motor and MAV R motor. And so I don't have to type those numbers over and over again. So, and then I want it to, let's just say 100 for now. And that's just the speed of it. And for both of them, 100. Great. So now, if I ran this program just right now, the robot would move forward at 100 speed, and then it would read this and do it, and then move on and read this, and then it exit the code. So this actually really wouldn't do anything. So I have to have an im sleep, which means millisecond sleep. And I would say, and since it's millisecond sleep, it takes milliseconds. So I'll say I'll move forward for 1 second. So this is 1 second right here. So if I ran this code right now, it would go forward at 100 speed, and then it would, for a second, and then it would stop. And then if I wanted it to, let's see, forward and backward, so if I wanted it to do backward, then I just make both of these negative right here. Great, so now I have this simple piece right here, and now what I'm going to do is I am going to make a function out of it. So, let's see, first we have to find a function name. This is just saying what it's going to return. It's not going to return anything because it's making the robot move. So all the functions have void. So let's name it move. Okay, and this is basically what your own little function looks like. You have to say what it's going to return, which nothing. You're going to say the name, and then you're going to have parentheses and then some curly brackets. The parentheses have the arguments, which I will explain later, and inside the curly brackets is what you actually get it to do. So I'm going to take this and I'm going to cut it and I'm going to paste it in here. So now we have something of a function. So now up here, if I said move, then it would run this. It would move backward for a second and then stop. But since this is a function, I want to make it more moldable, which means I want to be able to put numbers in these parentheses, and get it to change what's in here. So I'm going to use some variables for that. But first, whenever you make your own function, you need to define it. And so the program, when you run the whole thing, it knows what functions you have made because it knows there's a main function, but it doesn't know about the other one. So you have to tell it. So I'm going to say function declarations, and I'm going to say void move right there. So now we've declared that we have made this function right here. And now we're going to make it moldable, which means I'm going to be adding some variables to it. So what you can do with functions is you can put some variables in here and in this, right? So that if you put some numbers in here, then it'll change what this does. And I'll show you right now. So this right here, these, since it's only forward and backward, these two are always going to be the same. The only thing that's going to change is whether we want it positive or negative and the speed. So what we can do is we can say speed right here. So, and that means I need to say int speed, so I'm going to define the variable inside the function declaration. And so there's going to say, oh, there's a variable, an integer variable called speed. And then later, we're going to use it here again. So we have it defined up here, and we're going to define the variable. And then we're going to say we're going to use the variable in the function, and then we put it in here. Oh, I spelled it. Shoot. Okay. And then we can actually make it more moldable. So we can actually make this a variable too. We can say imsex. And then we would do int imsex. Imsex. So what this allows us to do is not only say how fast we want to go forward or backward, we say how long we want to go for that. So I'll show you right here. In this move, I called it right, but now I have two arguments. These are called arguments. Argument 1 is speed. Argument 2 is imsex, which is the milliseconds that you do it. So I have to have two values for that. So let's say we want a robot to go at 150 speed for 3 seconds. We'll say 150 for 3,000 milliseconds, which is really 3 seconds. So this number corresponds with this variable, which is used here and here. And this number corresponds with this variable, which is used here. And this, my friend, is a finished function right here. Now, let's move on to the next one. So we have that, and we've declared it, and we can move on. So next one, I want to be able to move forward and backward a certain distance. So I'm going to experiment in here. Now, moving forward and backward distances takes a different command, not the MAV command, but the MRP command, move relative position. And that uses ticks instead of time. And it takes 3 arguments in it instead of 2. So we're going to have 2 of these, MRP, MRP, and then we don't need an msleep because it uses ticks to dictate how long it goes. So the 3 arguments in the MRP, it takes the motor, it takes how fast you want to go, and then how many ticks you want to travel. And for those who don't know, a tick is a unit of measurement used to measure the position of the motor on a Botball robot. So, and it's also, yeah, that's what it is. So I think there's about 1,500 ticks in a wheel rotation. So if that's true, it might be 500. I think it's 1,500 though. So the first argument is going to be the motor. So we're going to say L motor because we have a variable up here so we don't have to type in the actual number. And see, the reason why I'm doing this L motor, R motor thing is because if you're using your robot and then you actually go to plug in the motor, but then you decide, oh, I want to use port 0 and port 1 and not 0 and 2. What you can do is all you have to do is change the number right here to 1, and then all of your code will be good instead of having to go through and change all of those 2's to 1's. So it just makes it more flexible. So MRP, L motor, this one is going to be R motor, and then we're going to go speed, which is going to be, I'll just say 200 for now. 200. And then it's going to be the ticks. And I don't know. Let's do a full motor rotation, I think. That's how many ticks it's going to travel. 1500. And if you were to use the function that I'm about to make, then what you'd have to do for your own robot is you'd have to do some experimenting to see how many ticks it takes to do, I don't know, like 10 centimeters, or how many ticks it takes to go 1 centimeter, and then you can do the math to scale up or down. But it takes experimenting. So this is what it would be right here, with some filler values right here, and now I'm going to make a function out of it. So I'm going to have void. Oh, well, yeah, let's do this first. Void, and then let's call it move ticks. Sure, we can do that. And then boom, boom, great. And now let's make sure not to forget to define it up here. Void move ticks, and then we will decide what variables we want to put in it. So here's the main function right here. We have a number right here and a number right here. And so I guess we're going to have 2 variables. We'll have int speed and int ticks. Great. And then we'll put it down here. Speed ticks. And the reason that I'm not saying int speed and int ticks is because I already said that up here. So the computer already knows that there is a variable called speed and a variable called ticks. And honestly, I don't even have to have this int right here because we already defined it right here. But I want to because it looks good. So let's copy or cut and paste it right here. And then we will put in the variables. So this is the speed place for, this is the second argument in the MRP command. Second argument is speed. So that's speed, and that's speed. And then this is ticks, and this is ticks. Great. So we've defined it right here. We've said what it does right here. Let's call it, and I'll tell you what it does do. So we say move ticks to call our made function, and then we say the speed, and we'll say 200 again, and we'll say 1500 for the ticks. So what this is going to do is, instead of having to type all this code right here, we just type the name of the function and then the arguments that go in it, and then the arguments travel from here, and then they pass through this, because it's saying, okay, we're using 2 variables, and it goes into this right here. So it's super easy. So this will go at 200 speed for 1 wheel rotation. You'll have to experiment to see how far that goes. Great. So this is done right here. So we can move on. Be able to turn left and right for a certain time. Great. So turn left and right for a certain time. The reason I'm not saying, well, we could do MTP, but I'm just going to stick with MAV for now because it's simple. So we'll have the setup. We'll have to have 2 motors and an msleep to say what's moving and how long it's moving. So we're going to, I know the first argument is motor, so we're going to do L motor, and we're going to do R motor. Great. And then the second argument is going to be the speed. So we'll just put in a filler value for right now, 100 and 100. And we'll put in a filler value for right here, 2000, which is 2 seconds. Great. Now it's turning. So that means that one of them has to be negative. So now we have this right here. And let's see. So one of them, okay, I know what we can do. So it's going to be, we're going to say void turn, and that's going to be our function name. Great. And then we're going to define it up here. Make sure not to forget to define it. Void turn. Great. And now we will take this and we will cut it and we will paste it in there. So L motor, left motor, right motor. Great. So we're going to take the speed of turning and we're going to take the time of turning, just like in this move. It's similar, but it's turning. So there's actually the only difference between the move and the turn is actually just one negative sign. It's kind of funny. So int speed and int imsex. Great. So then we'll put that down here, speed and imsex. And we will now put these variables in this right here. So I know for sure imsex goes there, obviously. Now the turning part. This is where you have to, when you're making this function, you as the programmer have to know it. And what I mean is by going to have speed here, and we're going to have speed here. But this is going forward and backward. So that means that we have to make one of these negative. And so then you have to decide, okay, well, if it's negative, do I want it to turn left or right? And I, as the programmer, am going to choose to turn left if it's negative. So then that means this one's going to be negative. Because if you imagine it in your mind, you have the left motor. Oh, actually, I have some fun pictures. Because who doesn't like pictures? Okay, no, they're gone. Never mind. So if you imagine in your mind, L motor is on the left side, and that's going backwards. And the right motor is going forwards, so it's going to turn it left. Yep, and I'm going to do it up here. I'm going to do turn. That's it. And it's going to do speed, so 100, and we're going to turn for 2 seconds, right? So this 100 is going to be taken down here, and it's going to be 100, negative 100, because it's negative, and positive 100. So the left motor is going to be going backwards. Now, if I made this a negative 100, that would be plugged into this speed, and a negative 100, add a negative to it, that's a positive 100. And then this speed is going to be negative 100. So it's going to turn the other way. So all you have to do is put that negative in there, and it'll make it turn left or right. And if I want to make it turn faster, I can make it a very fast number. That would be very entertaining. So, yep, I think that's be able to turn left and right for a certain time. Done. Okay, use a button, digital sensor, to move toward an object until it hits it. And we're going to be using the MAV and the digital commands. Okay, let's do it. So experiment in the main function. Give myself some more room. So to move toward an object until it hits it. So that is conditional. So that means we're going to have to use a loop. So I know we have to use a loop because it has to keep on checking for something, check until it hits something. So you have to use a while loop. So it's going to want to hit a wall. So it's going to be while the digital something equals 0. And I'll explain that in a little bit. We're going to be moving forwards. And we don't have an sleep, no sleep, because it's in a while loop, and I'll explain that also. So this right here, it's not complete yet, but I'm going to explain the logic. So while digital, this command right here, it calls on the output of a digital sensor that you plugged into the brain. So say you plugged a button into port 0 in the digital port 0. So what this would do is it would always be reading, okay, what is the button? Is it on or off? Is it 0 or 1? So digital 0 is going to be checking the state of the button. And if the state is off, which means it's not pressed, then it's going to move forward. And it's going to keep on checking until this equals 1. When this equals 1, when this equals 1, 1 is not equal to 0, so it'll exit and it'll stop moving. That's how it works. So we're going to fill in this. This is going to be L motor, and I don't know, let's just say 100. We don't have to have a variable. I mean, we could. R motor for 100, 1,000. Okay, so this is it right here. Let's put it in a function. So void, let's think of a name. What would be a good name? Say button bump. Great, classic. Okay, and then we will go ahead and copy or cut and paste this there, called button bump. Oh, let's go ahead and declare it. Void button bump. Great. And then do we want it to have any variable input? Because you don't have to. You could just say button bump and just do that, and then it would run whatever is in this button bump function. So that means it would always be port 0. Your button would have to be in the port 0, and it would go at 100 speed. So I think I'm fine, maybe 150, make it go a little bit faster. I'm fine with the speed being set. That's fine because you don't want to go too fast or else it might hurt your robot. But the port we can actually make into a variable, I believe. So let's go up here, variable, and we're going to say int, let's see, yeah, port number. Let's see, button, you can just say that, equals 0. Great. And this actually is going to go right here. Button. And okay. So the reason I'm not going to put it in here is because we've already defined it right here. The only time you put a variable in here, in these parentheses, like this right here, is if you're going to tell what the value is when you call it. I'm not going to tell what the value is when I call it, so I don't need to put the variable in the parentheses. It's already known right here. It's already defined right there. So that looks like it. We have button bump while the sensor that has the button on it is off. Then you're gonna move forward at this speed. And then when this is on and that doesn't equal 0, then you'll exit and you're done. Great. That is the button bump function. Wait, yes, we don't have any variables in it. Awesome, let's move on. So, use the ET sensor to tell me when I get close to an object, but not bump it. Okay, so that means we're going to be using the MAV and the analog. So whereas we used digital last time, we're going to use analog this time. So let's experiment. So this is going to be kind of the same thing as the one we did before. So it's going to be a while. Great. And then we're going to be using the ET sensor to basically move forward until you get close to an object. And that's the ET sensor is a distance sensor, and so it takes in light and it takes in reflected light that it sends out, and then based on the amount of time that the light takes to return back, it can figure out how far away something in front of it is. Super cool. They called it ET because it looks like a little alien. I mean, I think that's why they called it that. So while the this is an analog sensor, which means it returns a wide range of values. Digital sensors only return 0 and 1. So that's analog, and we'll just put in 0 for now. Analog, and then this is where you'd have to experiment because since the analog sensors give out a wide range of values, you will have to decide, okay, well, how far away do I want my robot to stop? And then you'll actually take the robot and you'll put the sensor on the robot and you'll put an object in front of the robot and you'll go into the settings. You'll go into motors and sensors, and then you'll click on sensor list in the robot when you're on the home screen, and you can actually find which sensor you're using, and then you can see the number that it's spitting out. And then you'll do some experimenting. So I'm gonna say I want my robot to stop 3 inches away from the object, and the closer the ET sensor is to something, the higher the number. So that means the number is going to be, say, 2,000. If the robot is 5 inches away, it's going to be 1,500. It's 4 inches away, maybe 1,700. 3 inches away, 2,000, 2,000. So let's say that. While the sensor is less than 20,000, because this is going to be low if it's far away, and it's going to be higher, getting higher, higher, higher. So as it approaches 20,000, as it approaches 3 inches, you're going to move forward. So we're just going to use the MAV command again. Great. And we're going to use our trusty variables, L motor and R motor. And we are going to say, what are we going to say? What speed? Say, that's a good speed. That's a good speed. 150, that's pretty slow. So the slower that you have your speed, the more precise that the more accurate that your sensors are going to be. That's just a trick that I've learned. So now we have this right here. Let's put it into a function. So we're going to say, I'm going to call it ET detect. Just for that's good enough. Let's see here. ET detect. Let's cut and paste this, and then we will go ahead and define it. ET detect up here. Void ET detect, so the program knows that we made our own. And now, do we want to put some variables in it? Yep, I'd say we want to do a variable for this, because this number is good. And then this number is good. We'll just have to change that manually when we figure it out, and then we can keep it the same. But ET detect should have a variable for the analog sensor. So we have a button, let's say int ET sensor. And we'll say that's in port 0 also, because there are a line of ports for analogs and digitals. So analogs go from port like 0 to 5 or 6, and the digitals go maybe from port 0 to 9. So more digitals ports than analogs, but both have port 0. So we have ET sensor is 0, and we're going to say ET sensor, and that actually means 0. And we're going to plug, so if we wanted to change our ET sensor to port 2 because port 0 got fried for some reason, then we'll just change it here, and it'll change it everywhere else. And then we have ET sensor. Then we don't need to put it in here because we've already set it right here. Great, because we're not defining it when we call the function. Let's see, ET detect, ET detect, right? We're not putting the sensor port right here. We have it up here. So we can just leave these empty, and then we call ET detect, and it'll run whatever's in ET detect. Easy peasy. Great, next one. Or last one actually, and most complicated too. I use the camera to face an object that has a color of my choosing, and we'll be using the MAV and the camera update. Yeah, camera update. That actually just means take a picture. Let's experiment. So I will use the camera to face an object that has a color of my choosing. So let's see. Let's use my handy dandy drawing board it's always helpful to use the drawing thing. Put it right here. Oh, there are my pictures. I thought I lost them. That's nice. Great. Okay, you decided to come back. Great. Okay, so these are the pictures I meant to show. Let's see here. Can I get ballpoint pen? This right here is for these two right here. For time in centimeters, that's what it looks like, just moving forward and backward using time in centimeters. And then this turning one is for this right here. And then this button bump thing is for this right here, just to illustrate what it looks like. It moves forward until the button turns to 1. 1 doesn't equal to 0. It stops. And then this ET detect function goes with this right here. It moves close until I said, what did I say? I said 3 centimeters right there. Now, for the last one, this camera that we're still brainstorming up here, let's say the object is to the left of the robot and the robot's looking straight ahead. This is its field of view right here. So we're going to start with a while loop because it's going to keep on checking something until it finds it. And so it's going to be while. Oh, well, we have to do some camera procedures first because if you want to use the camera, there are a couple of pieces of code that you have to do, which first you have to open the camera. Camera, what is it? Open? I think that's what it is. Let me see. I'll tell you right here. Where is it? Where did I put it? No, that's not it. It is Wallaby Library. Very helpful. Um, so camera right here, and camera open. That's it. So go back and get my drawing thing up again. So camera open, and then at the end of the function, right before the return statement, you'll say camera close. That's just procedure that you need to do when you use the camera. You need to open it to get it to take pictures, and then you need to close it off to shut it down. So then we're going to take an initial picture, so the while loop has something to process. So camera update, and let's give me some space here. Okay, so it's going to take a picture, and then it's going to say while. What's it going to do? So it's going to. Okay, so it's not going to be looking at anything at first. So get object count of, I don't know. Let's just say channel 0. So I'm going to write a little note for you guys here. The channels, there are 4 channels that you do. And I actually did a video on this. So if you're confused about the channel and configuration, whatever, you can go see that. But there are 4 channels that the camera takes, and each channel is assigned to a color. And each channel actually has a number to it. And you can configure that in the settings of the robot. So let's say, just to make it up, we'll say channel 0 is going to be red. Channel 1 is going to be green. Channel 2 is, say, blue. Blue. And channel 3 is pink. These are all colors that we use on the Botball board because they're like pom-poms, which are little like cotton ball sized colored things that the robots pick up, and then there are cubes, and this is one of the cubes, and we're going to say that this cube is red. So there we go. We have a red cube now. Great. Awesome. So we're looking for a red cube. So channel 0 is red, so we're going to say get object count of channel 0, which is red. And it's going to return how many objects it sees. So we're going to say while it equals 0, while the objects that it sees, there are no objects, you're going to turn. And it's going to keep on turning around like this until it sees something. So this is a 2-part function right here. So we're going to use the MAV command again. MAV, and we're going to say L motor, and we're going to say R motor. Great. And now we have to, so this picture, the object is to the left. It's right here. So that means we need to keep on turning it to the left until we see it or see something. So if we're going to turn to the left, we're going to say negative 150 and 150. The trick I use to figure out which way to turn or which one is negative is the one that's negative, that's the way it's turning. So we're going to say L motor's negative, so it's turning left. Let's see. So it's going to keep on turning until this is not true. It's going to exit the loop. Oh, well, there is something very important. We need to put a camera update in there because it needs to keep on taking pictures so it can refresh every single time. I think I'd actually want to put that at the end, right? Would I want to do that at the beginning or the end? So it's going to take a picture and then it's going to check yes or no. If yes, then it's going to do this. We're going to take another picture, check, do it, take another picture, check, and then if that, yeah, so put it at the end. Great. So then we're going to have a while loop, another one, because now the robot sees the object, but now it needs to point directly toward it. Face an object that has a color of my choosing, not just see it, it needs to face an object. So that's what we're going to get it to do. Right now, the robot can kind of find the object right when it comes on the view of the camera, but now we want it to face it. And that we're going to use using the center of the object. So while, let's see. So I know I'm going to need a camera update in it, which is going to go at the end. And I know I'm going to need these mavs. And just filling in everything I know because sometimes the logic of cameras can be difficult. So L motor and R motor, great. And then what are we gonna do? We're gonna keep on turning left. So left motor is gonna be negative then because that's my neato trick. And so we have that. And now all we have to do is put something in here and we're done. But what do we put in there? So we're going to use the center of the object. So now we see the object. Now we can use the center of the object. So get object center X, which will get the center of the object. Object, still using channel 0, and channel 0 is red. Let's see here. Take a look at the archive again. Where is it? No, it's not there. It's right here. Camera. Where is it? Get object center. Channel object. Oh, that's it. That's right. So this get object center X, it takes two arguments. What channel you're using, basically what color, and then which object. Because there can be multiple objects on the screen, but it has to know which object to get the center of. 0 is the largest object, then 1 is the next smallest, 2 next smallest, etc. So I always use 0 because I'm always tracking the biggest object. So that's going to find the center. And since we know for sure that the object is to the left, this is what it's looking like right here. This is the X, this is the Y, this is the top of the camera view, and this is the bottom. So, write it all out, gosh. Okay, so this is what the camera sees right here. So if the object is over here, right, then we need to keep on turning left until the object comes into the center. So over here is 0 pixels, over here is around, I don't know, 160 pixels, I think it is. So that means then while it is less than, I don't know, 80, because it's over here right now, so it's a 0. So it needs to keep on going toward 80 until it gets there, stops, and 80 is around the center. So that looks like it right there. Now let's make a function out of it. So we'll go down here and I'm gonna say void find object. Great. And then we're gonna say gonna cut and paste all of this right here with the notes and everything. paste right there. And the reason I am leaving this camera open and camera close up here is because if I put it right here, anything I put in between here is gonna be able to use the camera because I've already opened it. Anything before this is closed. So I don't want to put it in a function because then I would have to open it and close it for every single function. Why not just leave it open for the entire program? So if I ever want to use the camera, it's already open. That's a great idea to me, so that's why I'm keeping it there. Now down here, find object. Do we want to have any variables? Yes, we do. We want to say what color object we want to find. So let's go up and make a variable out of it. So int channel. And I'm saying channel instead of color because there's channel 0, 1, 2, 3. And actually, what I'm going to do is not put these precious notes down here. I'm going to put them up where the variables are. So let's see, channel. And then boom, right there. There are some helpful notes for our example program. These can change depending on what you set it to, but in this program, that's what they're going to be. So channel is going to be 0 because 0 is red and we're tracking a red object. There it is. So we're going to come down and we're going to be using a channel, the channel variable that I just made right here. And we're going to make sure to define it. Yeah, find object. Define it so the computer knows that we made our own function. Find object with int channel, which I don't actually need to have it right here because I'm defining it when I call the function, not before. So int channel find object, that's our only variable. Find object channel right here. And it doesn't go here because if it went here, then I would be defining it beforehand, but it's going to be different every single time I want to find an object. Let's say I do find object and I have 0, right? What if I want to find a different object? Find object, and I want to find a pink object because 3 is pink. Then I'm going to define it right here. If I defined it right here, up where these guys are, I couldn't have these two because channel is already defined right here. It's only one value. But if I define it in the function, I can have multiple values. So it's going to run the find object function with 0 as the input and then with 3. So the channel is going to be 0 and then it's going to be 3. And I actually have to put in the channel. So this is going to be channel and this is going to be channel. And this is going to say 0 because you're always going to be tracking the biggest object. Yep, so let's see. Use the camera to face an object that has a color of my choosing. MAV and the camera. Right here, takes an initial picture. It looks for the object, then it directly faces the object using pixels and the center of the object. I think that we are done. So I will show you the function that I found that moves the server slowly instead of quickly. Yes, we're not done yet. Got to show you that one because that's very helpful if you have a delicate claw and you don't want to move the claw fast. So I'm going to use that, and that function uses a for loop instead of a while loop. So I guess I'll explain what that is also. So the for has 3 arguments in it, 3 things that go in the parentheses. It takes a counter variable, which I think that's that, and then it takes like a continuation limit or like how long to do it for, while this is how I read it. There's a counter variable called I, while I is, I don't know, just less than 100, add 1 to I every single time you repeat the loop. Or you could say I equals I plus 1. But that's kind of boring. So if you ever want to just add 1 to it every single time, you'll do that. But because this is controlling how fast the servo goes, we actually need to do it the long way. So we can control how fast to move it, and I will show you. So for int I, and then we're going to be controlling the servo. So that's set servo position of the servo. Oh, and then sleep for 10 milliseconds, and I'll explain that also. So set servo position, it takes two inputs to it, two arguments. It's which servo port you're using and to what position you want it to go. So we'll just say a filler variable, port 0, and we'll say we want it to move to 500. Boom. So what this is going to do, let's see, actually we need to change this. Well, I is going to be, yeah, I is less than 100. No, 500. And then this can start at 100 for now, but that's not going to stay like that. So what this is doing, there's a variable called I, and while I is less than 500, you're going to add 3 to I every time you repeat the loop. So it's going to keep on repeating the loop until I equals 500 or is above 500. So since I is moving at a certain rate, we can actually use I as the position of the servo. So instead of snapping up as soon as you tell it to go somewhere, it's limited by how fast this for loop can go. So there are variables that we'll need to put into this. First, let's make a function out of it. So when I use this, I call it slow servo. Would slow servo, and let's see, give me some space. Let's see here. Slow servo, we're going to cut and paste it. Cut and paste. Now let's not define it yet, because let's add in all the variables first. So what variables do we want? We want which server we're moving, and then we want to where we want it to go. And it'll always move slow, so we don't need to make that into a variable. This is actually controlling the speed of the servo. So if you like use this thing right here, you can actually mess around with it and see how it moves a certain speed, moves certain speeds, different speeds. Like if I increase this to 5 right here, it's gonna actually move like visibly faster than if it was 3, because that's how it works. So that's I right here. We've defined I right here, and so we don't need to define it out up here. But we do want a servo variable and a position variable. So let's go ahead and define it. Slow servo, void slow servo, and then we want int, what did I say, port? Can't remember what I even said. Servo position. Servo int position. So we defined it. The program knows that we made our own function. Now, slow servo, we have servo right here and position. Now we need to put it in here somewhere. So let's see. This is the same. This is controlling what position. So position. Let's see. While I is less than position, move upward until you get over that position. And then this is actually going to be servo right here. So set servo position, the two arguments it takes is which server you're using and what position you want it to go. And this is going to be the continuous position right here. And that's why it's going to move slow. Instead of immediately snapping to the position that you want, it's going to be limited by how fast this for can loop. And then that servo, and then, okay, I have this right here because if you didn't have it, what would happen is the loop would go so fast that it would just immediately snap. So what you have to do is you have to slow it down a little bit and put a little delay in there, and so it will kind of slow down. And if you take this piece of code and you experiment with it and you take that out, you'll see. You'll see what I mean. So we're almost done, but we have a problem. Because what if the servo is at a starting position of 800 and I want to move to 500? That is a problem because this can only go up. It can't go down. So we're going to have to add some more logic, I believe. So there are either two scenarios. You can either be moving up to a position, like we're assuming that it is, or you can move down to a position like this. So we can use an if for that. If, oh boy, how do you do this? Let's see. Okay, we're gonna have to use another command. Get servo position of the servo that we're using, so we can just say servo. And I'm gonna check that right now, make sure I'm not crazy. Servo, see, back, servos, there it is. Get servo position int port. That's what it is. Great. So we have this and we have that. Now get servo. Okay, gosh, there it is. So if get servo position of the servo that we're using is greater than, no, less than the position that we want to go to, then we'll use this right here. Because if the current position is less than the desired position, we have to go up from the current position. So we'll use that right there. Boom, boom, boom. And then we will go ahead and paste that in there. Boy, formatting, what you gonna do? Great. Now we're gonna do the other. We're gonna just do an else if. I'm not gonna do an else because who knows what would happen if I left it open-ended to the program. So else if this copy is greater than, we will have to do exactly this, but move downwards. Then I think we actually have to switch this also. And let's see. Is that it right there? Good. Good. And so else if. So if the current server position is less than the desired position, then we're going to move up. And we're going to keep on moving up while it's less than the desired position. If the current position is greater than the desired position, then we are going to keep on moving while we are above the desired position downwards until we get below it, then it'll stop. Yep. Okay, let's see. Let's see here. So I will also show you the function that I made that moves the servos slowly instead of quickly. So this is all it right here, and I, with you, just wrote all this code right here. And if you ever wanted to use any of these, look, you can see all the functions that you made right here. And so if you ever want to use them, you just look up here. Okay, I want to move at 150 for 5 seconds, and then I want to I want to turn right, and I remember right is positive. I want to turn really fast for 1 second, and then I want to go until I bump something. So button bump, okay, button bump, and that doesn't take any input. And then I want to move backwards for 150 for, I don't know, 2 seconds. And then I want to turn left, and left is negative for a second. And then I want to find object channel 2, which channel 2 is blue. So find a blue object, and then you'll end your program facing that blue object. So this has been a little tutorial on how to make your own functions, and in that being able to make your own programs. Imagine if all of these individual pieces of code were in here, instead of in functions. It would be miles long. When I first started, that's all my programs were, just blocks and blocks and blocks and blocks and blocks of code, and I would have to scroll way down just to find wherever I wanted to go. But with functions, you can reuse all your code, so it's a lot shorter. Like this could be a whole program right here. So there you go.